Right now, somewhere beyond the edge of the solar wind's reach, a spacecraft the size of a small car is falling through the dark at over 60,000 kilometers an hour, carrying a golden record etched with the sounds of Earth. Whale song, a mother's laughter, Bosch, and greetings in 55 languages, toward a destination it will never actually see, following a straight line that no one is steering anymore. What if, instead of drifting forever through the emptiness between the stars, that line ended somewhere unexpected? What if Voyager 1, humanity's most distant machine, actually reached the end of its journey by slamming into the surface of another world? It sounds like the beginning of a science fiction story, and in a very real sense, it is one. Because, as we'll see, the odds of this ever happening are so vanishingly small that it belongs more to imagination than to prediction. But the question is worth asking anyway, because chasing it honestly takes us somewhere far more interesting than a simple yes or no. It takes us through the true physics of what Voyager 1 actually is right now, how fast it's moving, where it's headed, what it would mean for a human-made object to survive a journey of tens of thousands of years, and what it would say about us if, against every probability, someone or something out there ever found it. To understand why this thought experiment matters, we first need to appreciate exactly where Voyager 1 is today, because most people's mental picture of it is stuck in 1977, the year it launched. As of 2026, Voyager 1 is roughly 25.5 billion kilometers from Earth, a distance of about 170 astronomical units, meaning it is more than 170 times farther from the Sun than we are. It crossed the heliopause back in 2012, leaving behind the bubble of solar wind and magnetic field that surrounds our entire solar system, and became the first human-made object to enter true interstellar space, the region between the stars, where the material drifting around is no longer dominated by our Sun, but by the combined debris of the galaxy itself. Later this same year, in November 2026, Voyager 1 is set to cross another remarkable threshold. It will become so distant that a radio signal traveling at the speed of light will take a full 24 hours just to reach it. Susie Dodd, the Voyager project manager at NASA's Jet Propulsion Laboratory, has described what this actually means in practice. If mission engineers send a command on a Monday morning, they won't hear anything back until Wednesday morning. 2 days, simply to say hello and get a reply. It's a strange kind of loneliness, built entirely out of distance and the unbreakable speed limit of the universe, and Voyager 1 is not the pristine machine it once was. It launched with 11 scientific instruments, and by 2026, only a handful remain functional. Its power source? 3 radioisotope thermoelectric generators that convert the heat of decaying plutonium-238 into electricity, produced about 470 watts at launch. Today, that number has fallen to somewhere around 250 watts, and it keeps a year. Engineers at JPL have spent decades managing this slow bleed of power like a household budget stretched to its absolute limit, switching off heaters, shutting down instruments one by one, prioritizing whatever keeps the spacecraft transmitting for just a little longer. The cosmic ray subsystem was switched off in February 2025. The low SPI, energy-charged particle instrument, followed in April 2026. Engineers have even nicknamed an upcoming software patch the Big Bang, a last attempt to squeeze a bit more life and even restore some capability to a probe that has already outlived every original expectation for its mission by nearly half a century. Current estimates suggest Voyager 1 will likely go silent sometime in the early 2030s, when its power finally drops below the threshold needed to run even its most basic systems. After that, it won't stop moving. It simply won't be able to tell us anything more about where it's going. And where it's going is, on cosmic terms, nowhere in particular, at least not on any timescale a human being can meaningfully imagine. Voyager 1 is moving at around 17 kilometers per second relative to the Sun, which sounds extraordinarily fast, fast enough to cross the distance between New York and Los Angeles in a few minutes, and it is fast by human standards. But space is so overwhelmingly empty that even at that speed, the spacecraft is essentially crawling through a void so vast that fast barely registers. Right now, Voyager 1 isn't headed toward any star in particular. It's simply moving outward along the trajectory it picked up from its final gravitational slingshot past Saturn back in 1980, an arc bent by the giant planet's gravity and then locked in place. Forever, since Voyager 1 has had no propulsion capable of steering it in over 4 decades. But interestingly, stars themselves are not fixed points sitting still in the sky. They are all in motion, orbiting the center of the galaxy, drifting through space at their own individual speeds and directions. And over long enough timescales, some of them will happen to cross paths with Voyager's line of travel. NASA has actually calculated this. In roughly 40,000 years, Voyager 1 will pass closer to a red dwarf star called Gliese 445, also known by the older designation AC +79 3D88. than it currently is to our own sun. Gliese 445 is a small, dim star, about a fifth of the mass of the sun, sitting in the constellation Camelopardalis. And right now, it's still many thousands of light years away and is moving toward our part of the galaxy at more than 100 kilometers per second. By the time the two paths draw close, in that same 40,000-year window, Gliese 445 itself will be only a few light years from where our sun currently sits, and Voyager 1 will pass within about 1.5 to 1 7/10 light years of it, depending on which calculation you consult. That is still an immense distance, roughly 10 trillion miles, a gulf so large it would take a beam of light, itself well over a year to cross it. It is, in astronomical terms, a close encounter, but by any human measure, it's a flyby, so distant that encounter barely feels like the right word. There is no planet in this story, no surface, no landing. Just two objects, a dying spacecraft and a small red star, sliding past each other in the dark, close enough to be gravitationally notable to an astronomer, and still separated by a distance that would take tens of thousands of years to close even at Voyager's own considerable speed. So here's the honest scientific answer buried inside our thought experiment. Voyager 1, crashing into an alien planet, is, as far as we currently understand orbital mechanics and the structure of nearby star systems, essentially impossible. Interstellar space is staggeringly empty. Even within a single star system, planets occupy an infinitesimally small fraction of the available volume. Tiny points of rock or gas scattered across billions of kilometers of essentially nothing. The chance of any object moving in a straight line, with no guidance system, happening to intersect not just a star system, but a specific planet within that system, is so close to zero that astronomers generally treat it as zero. Voyager 1 isn't going to crash into anything, for the same reason that if you fired a bullet from Earth in a completely random direction, it would almost certainly never strike another bullet fired from another galaxy. The universe has an enormous amount of nothing in it, and spacecraft moving without correction simply sail through that nothing forever, or at least for a very, very long time. But essentially impossible is not the same as physically impossible, and asking what it would actually mean is where this thought experiment earns its keep, because it forces us to reckon with just how different Voyager's future is from anything in its past. If, against every probability, Voyager 1's path had been aimed with enough precision to actually strike a planet somewhere out among the stars, the encounter would look nothing like the gentle landings we're used to from movies, or even from our own missions to Mars. Voyager 1 has no engines left, no fuel to slow itself, and no ability to change course. Whatever velocity it's carrying at the moment of impact is what it would deliver, and given that stars and their planets are also moving, that combined relative velocity could easily be tens of kilometers per second, possibly more. At those speeds, an impact isn't a landing. It's an event closer to a small explosion, converting the spacecraft's entire kinetic energy into heat and light in a fraction of a second. The elegant array of instruments, the whisper-thin, high-gain antenna, the golden record with its careful engravings, all of it would likely be vaporized or shattered into debris almost instantly, scattered as microscopic fragments melted into or blasted across whatever surface it struck. There would be no dramatics. Scene of a probe resting intact on alien soil, gleaming and readable. There would be, more likely, a tiny fleeting flash, a small crater, and then nothing. Unless, of course, the planet in question had no atmosphere and a surface with very particular properties, or unless the impact happened at a much shallower angle and lower relative speed than we might expect, in which case some fragments could conceivably survive. This is actually a question astronomers and engineers have thought seriously about, not for Voyager's hypothetical planetary impact, but for its actual fate drifting through the interstellar medium for the truly deep future. Space isn't a perfect vacuum. It contains sparse clouds of dust and gas, and over millions or billions of years, the slow sandblasting effect of interstellar particles striking a spacecraft at high relative speed can genuinely erode its surface. Researchers have estimated that the physical structure of Voyager 1 and the golden records the twin Voyagers carry could survive this kind of erosion for perhaps 1 billion years or more, which is a genuinely staggering number. 1 billion years is enough time for the spacecraft to complete roughly 4 full orbits around the center of the Milky Way galaxy. It's enough time for continents to have rearranged themselves entirely, for entire species to rise and vanish, for the sun itself to visibly brighten as it slowly ages. On timescales like that, some researchers have even mused about the strange possibility that Voyager 1, or its inert twin, might still be recognizable, a pitted and weathered artifact, when our own sun and Earth eventually merge with the Andromeda Galaxy in an event predicted to unfold a few billion years from now. In that light, the idea of Voyager surviving long enough to eventually, by pure chance, intersect a planet somewhere in that unimaginable stretch of time doesn't feel quite as absurd, even if the odds on any given day, any given millennium, remain incredibly small. This is where the golden record becomes the real emotional center of the thought experiment, because it was designed from the very beginning with exactly this kind of impossible, improbable, patient future in mind. Carl Sagan and his team, who assembled the record's contents in 1977, understood that Voyager was very unlikely to ever be found by anyone. They built it anyway, as an act of hope rather than expectation, a message in a bottle thrown into an ocean so large that the chances of it ever washing up on a distant shore were almost too small to calculate. The record contains 90 minutes of music from cultures across the globe, sounds of thunder, wind and animals, greetings recorded in dozens of human languages, and images encoded in analog form showing our biology, our mathematics, our planet, and our daily lives, along with instructions etched directly onto the record's cover in symbolic diagrams for how an intelligence with no shared language might play it and decode it. If Voyager 1 ever were, somehow found intact by another form of intelligence, whether it landed gently in some improbable soft touchdown, or was recovered by beings advanced enough to intercept it in deep space long before any collision occurred, that golden disk would be the entire message. Not a threat, not a demand, but a single offering. This is what a small water world circling an ordinary yellow star once sounded like, once looked like, once dreamed about. There's something worth sitting with here in the sheer improbability of it all, because it mirrors one of the deepest open questions in modern astronomy. We now know, thanks to missions like Kepler and TESS and the ongoing work of ground and space-based observatories, that our galaxy alone likely contains billions of planets, many of them rocky, some of them sitting in the so-called habitable zones of their stars, where liquid water could exist on the surface. And yet, despite all of that abundance, we have never once received a confirmed signal, a confirmed artifact, a confirmed sign that any of it holds someone looking back at us. This is the heart of what's known as the Fermi paradox, named after physicist Enrico Fermi, who reportedly asked, if the universe is so vast and so old and intelligent life should in theory be common, then where is everybody? Voyager 1, in its own small way, is one of our few actual physical attempts at an answer, a genuine object launched outward carrying evidence that we exist, rather than merely a radio signal that fades and vanishes. It is not a search for aliens, so much as a quiet declaration that we were here, whether or not anyone is listening. And this brings the thought experiment full circle, back to that opening image of a spacecraft falling silently through the interstellar dark. Even though the mathematics tells us clearly that Voyager 1 will almost certainly never strike a planet, will almost certainly drift onward for millions or billions of years through the emptiness, between stars without ever meeting a solid surface again, the question, what if it did, turns out to be less about physics and more about meaning. It forces us to imagine the moment differently, not a violent collision, but perhaps a discovery. Not an ending, but a message finally reaching a reader, somewhere, tens or hundreds of thousands of years from now, long after every human alive today has been forgotten, long after the last engineer who ever sent Voyager a command has turned to dust, the spacecraft could still be out there, tumbling gently through the dark, carrying its little golden disk waiting for an audience it may never have. Perhaps that's the real answer to the question we started with. Voyager 1 was never built to crash into anything. It was built to keep going, past the point where it could still talk to us, past the point where any of its instruments still work, past the point where humanity itself might still exist to remember why we sent it. It is not a probe reaching for a destination. It is a message set adrift on the largest possible ocean, moving at a pace that makes our entire recorded history look like the blink of an eye, carrying with it the sound of a mother's laugh and the shape of a double helix and the outline of a hand, on the impossibly small chance that somewhere, sometime in the vast quiet between the stars, someone else is out there to pick it up.